Okay, here we are. Today is day 16 on the advent of Cyber Challenge. Today's challenge is Forensics, Registry Furensics. And as always, my disclaimer, I'm not a cybersecurity professional. I have no experience in or with cybersecurity. So you'll see me as a beginner taking on these challenges just like other beginners would. And with that being said, today's day 16. Another disclaimer, my kiddo's just been up and down with being sick, so I'm playing catch up, which seems to be like week to week here. So I'm about 4 or 5 days out. As you can see down here, today is December 20th, and we're only on challenge 16. So as always, we have our 2 videos associated and 2 tasks as well. Task 1, introduction. Task 2, investigate the gifts delivery malfunctioning. And here we go. So I do see that we have a machine, so I'm probably going to go ahead and launch that real quick. Okay. And we are in split screen, so let me go ahead and pop that off in full screen here. And let's close this, get some real estate back. All right, and let's go back to the top. And one last thing, let me go ahead and bring my screen brightness up just a tad so I can see. There we go. Okay, TBFC is under attack. Systems are exhibiting weird behavior, and the company is now feeling the absence of its lead defender, McSkitty. However, McSkitty made sure the legacy continues. I'm still so confused with this entire story because, of course, we went 9 days of her not being there. Day 10, day 11, she was there, and now we are noticing that she's gone again. Anyway, McSkitty's team, determined and well-trained, is fully confident in securing all the systems and regaining control before the big event, SOCMIS. They have now decided to conduct a derailed forensic analysis on one of the most critical systems of TBFC, which is Dispatch-Server 01. The Dispatch Server 01 coordinates the drone-based gifts delivery during SOCMIS. However, recently it was compromised by King Malhair's Bandit of Bunnies, and I can see we have our IP associated here for our target machine, so 1081.168.107. My machine's loaded here, and zoom is good. Okay. Let's keep moving on here. So TBFC's defenders have decided to split into specialized teams to uncover the attack on the system through detailed forensics, while some of the other team members investigate logs, memory dumps, file systems, and other artifacts. We will work to investigate the registry of the compromised system. So definitely know we're working with the Windows system, as we saw here. And learning objectives today, we're going to understand what the Windows registry is and what it contains. We're going to dive deep into registry hives and root keys. Oh, this is going to be super boring for me, but hey, that's just me. Anyway, analyze registry hives through the built-in registry editor tool. Learn registry forensics and investigate through the registry explorer tool. And connecting to the machine. So of course we need to review our questions and connection card here. So no attack box, yes to VM, yes to split screen, no direct link, and no credentials to connect via RDP, VNC, or SSH. Of course here, this is just explaining how we start the target machine, and we did that by clicking the Start Machine button. And if we want to connect, alternatively, if you can use credentials below to connect to, oh, but it says we don't have the ability, but we do, but we don't. Okay. Anyway, we're going to go ahead and check this off. Beautiful, 21 days. And task 2, we're going to investigate the gifts delivery malfunctioning. So we have registry or Windows registry. Our brain stores all the information that we need to function effectively. This includes how you should behave, what would the first thing you would do after waking up, how you would dress yourself, what your habits are, what happened in the recent past. I'm going to go ahead and bring this in just a bit more here. These are just a few things. Your brain knows pretty much everything about you. It's just like a database storing the human configuration. Windows OS is not a human, but it also needs a brain to store all the configurations. The brain is known as the Windows registry. The registry contains all the information that the Windows OS needs for its functioning. And if we need to know what OS is, of course, you can click this here, operating system. Anyway, moving on. Now the Windows brain registry is not stored in one single place, unlike a human brain. That sounds a lot like Windows. It's not stored in one single place. unlike a human brain, which is situated in one single place inside the head. It is made up of several separate files, each storing information on different configuration settings. These files are known as hives. And I'm certain Windows makes this unbelievably simplistic to understand. Hint of sarcasm. Anyway, let's take a look at all these hives in a table below. The first column contains the hive names. The second column contains the type and configuration settings that each hive stores. And the third column, of course, contains the location of each hive on the disk. So we have hive name, system, and we have contains, services, mounted drives, boot configuration, drivers, hardware. We have our file path location here. Then we have security, which also contains local security policies, audit policy settings, and our file path here. Software, which contains installed programs, OS version, and other info. Auto starts, program settings, and our file path here. We have SAM, which is usernames and their metadata, not media data, password hashes, group memberships, and account statuses. Then we have ntuser.dat. So one thing I would like to do is let's go ahead and go to Duck.ai. And we're good here. In Windows registry, what is SAM? I'm assuming some kind of account management, but I'm not certain. So security account manager, yes. Okay. What is ntuser.dat? If I can spell correctly, let's check that out. This is a critical file in the Windows operating system that stores users' personal settings and preferences. Cool. So of course we see that here. So we see the contains recent files, user preferences, and user-specific auto starts. We see our file path here, folder path. Then we have usrclass.dat, and that has shell bags and jump lists. Well, of course, what is going to be USR, what was it, class? Yes. .dat. So USR is another important file in the Windows operating system primarily associated with user profiles. Fair enough. Folder path here. Our note, the configuration settings stored in each hive listed above are just a few examples. Each hive stores more than these. And now that we understand where these registry hives are stored, we may be tempted to double-click and open these files from their respective locations to view the data they contain. But here's the twist. These registry hives contain binary data and cannot be opened directly from the file. So double-clicking them would only display things you won't understand. Then how can we possibly view the registry data? Well, that's a good question. The Windows OS has a built-in tool known as the Registry Editor, which allows you to view all the registry data available in these hives. You can go ahead and open this tool by simply typing Registry Editor in your search bar. So I'm assuming, do we follow along here and just open what we need? So let's come in here, Windows. Wait a minute, this isn't a real Windows. I don't see a bunch of ads in here. Search. So we select this. Okay. We see this here. As you can see, the registry editor screenshot above, there are some folders named hkey _ local _ machine, hkey _ current _ user, and more. But didn't we expect system, security, and software, etc. to be seen so we can view their data? Don't worry, Windows organizes all the registry hives into the structured root keys. Nice, it's highlighted word, but you can't learn about it from here. So I assume, come here to Duck.ai, what are root keys? Root keys are the top level keys in the Windows registry and serve as the primary organizational structure for all the data stored within the registry. Each root key contains several subkeys and values that help manage hardware, system settings, user preferences, and application configurations. Okay. So instead of seeing registry hives, you would always get these registry root keys whenever you open the registry. Now, which registry key contains which registry hive's data? To answer this question, we have a table below that maps the registry keys with their respective registry hives. So we see system, then we see HKey local machine / system, security / security, software / software. Then we have SAM, and we can see / SAM, ntuser.dat, and we can see HKey_users / SID and HKey current _user. And for usrclass.dat, we can see kind of the same path, if you will. And this is HKey_users / SID / or backslash. I apologize. I keep saying / software and / classes. In the table above, you can see that most of the registry hives are located under the HKey local machine, HKLM. We can verify this by clicking on the little toggle arrow at the left side of the HKLM key in the registry editor as shown in the screenshot below. So we can click drop down and we can see that here. So click here. Oh, look at that. We did find it. Okay, perfect. And as we can see, system, software, security, and SAM hives are under the HKLM key. ntuser.dat and usrclass.dat are located under HKey users. So we could probably drop this one open and, well, I don't see it specifically, so nothing like jumping right out. Anyway, note the other two keys, HKey_classes_root, HKCR, and HKey_current_config, HKCC, are not part of any separate Hive files. They are dynamically populated when Windows is running. So far, we have learned what the registry is and where it is located in separate registry hives, and how to view the registry through the registry editor, which displays the registry keys. I just feel like we keep repeating that word over and over and over. And here we go, one more time. The registry keys backed by the registry hives. Now let's see how we can actually extract information from the registry. We should do a game, like take a sip of something every time you gotta say the word registry. Think of it like navigating to different files in the File Explorer. If you know the path where the file is stored, you can go directly to that location to find the file. Let's take a look at a few examples. Registry, just kidding. So example 1, view connected USB devices. Note the registry key, bam, got another one. Contents explained in the example are not available in the attached VM. The registry stores information on the USB devices that have been connected to the system. This information is present in the system hive. To view it, we would open the registry editor, navigate to the following path, which would be HKey_local_machine /system /current control set /enum /USB store. Holy moly. Here you will see the USB devices information, make, model, and device type. So the registry stores information on the USB devices that have been connected to the system. The information is present in the system hive. Dang. So here you will see the USB devices information, make, model, and device ID. Each device will have the following: a main subkey that is identification of the type and manufacturer of the USB device, and 2, a subkey under the above, for example, that represents the unique devices under this model. So here they went to HKey local machine /system. So we'll do system. And then it was control, current control set. Then it was enum. All right, and then I don't remember what it was after that. Enum USB store. Oh, okay. Well, I don't see a USB store in my area. Under UMB, I see UMB. Okay, so we'll just kind of pretend like we found this. Example 2, we can view programs run by the user. The registry stores information on the programs that the user ran using the run dialog when plus R. This information is present in the net user, or NT, I should say, nt-user.dat hive. To view it, open the registry editor, navigate to the following hkey underscore current underscore user / software, and so on and so forth. So we're going to go ahead and click into software, Microsoft Windows current version. So scroll down. H key. Oh, current user. Well, let's try doing that. Then system. Then, man, why don't you follow directions? It's not system. Software. Now. Go to Microsoft, then go to Windows, then current version. So scroll down, Windows, current version, last but not least, Explorer, and run MRU. Explorer, run MRU. Okay. Here you will see the list of commands typed by the user in the run dialog to run applications. So for us, it looks like nothing. Now, Registry Forensics. Since the registry contains a wide range of data about the Windows system, it plays a crucial role in the forensics investigation. Registry Forensics is the process of extracting and analyzing evidence from the registry. In Windows digital forensics investigations, investigators analyze registry event logs, file system data, memory data, and other relevant data to construct the whole incident timeline. So the table below lists some registry keys that are particularly useful during forensic investigations. So we can see here, HKCU, software, Microsoft Windows, current version, Explorer, user assist. And the importance of this is it stores information on recently accessed applications launched via the GUI. Then we have this one here, HKCU, software, Microsoft Windows, current version, Explorer, typed paths. And it stores all the paths and locations typed by the user inside the Explorer address bar. Then we have HKLM, software, Microsoft Windows, current version, app paths. It stores the path of the applications. Then we have HKCU, software, Microsoft Windows, current version, Explorer, word, wheel, query. It stores all the search terms typed by the user in the Explorer search bar. HKLM, software, Microsoft Windows, current version, run. It stores information in the programs that are set to automatically startup programs, when the users log in. Holy moly. HKCU / software, Microsoft Windows, current version, Explorer, recent docs. It stores information on the files that the user has recently accessed. Okay, I'm not going to lie. I did kind of like say this is going to be a little bit boring, but this is kind of neat that this is how you can find some information out on a particular device, or asset, if you will. And then we have HKLM, system, current, control set, control, computer name. It stores the computer's name, the host name, if you will. And HKLM, software, Microsoft Windows, current version, uninstall. It stores information on the installed programs. So, numerous other registry keys can be used for extracting important evidence from Windows systems during an incident investigation. The investigation of the registry keys during the forensics cannot be done via the built-in registry editor tool. It is because the registry analysis cannot be done on the system under investigation due to the chance of modification. So, we collect the registry hives and open them offline into our forensics workstation. However, the registry editor does not allow opening offline hives. The registry editor also displays some of the key values in the binary which are not readable. So what does that mean for us? So to solve this problem, there are some tools built for registry forensics. In this task, we will use the Registry Explorer tool, which is a registry forensics tool. It is an open source and can parse the binary data out of the registry, and we can analyze it without the fear of modification. So our practical example for today, in the practical example, we will use the Registry Explorer tool to analyze the registry hives for compromised system dispatch-serve01, and the registry hives have been collected and are available in the folder such as users, administrator, desktop, registry hives on the machine attached to this task. So step one, we need to launch the Registry Explorer. So we're going to click on the Registry Explorer icon pinned to the taskbar of the target machine to launch it. So let's close this. I'm assuming this one here. Registry Explorer, perfect. Maybe. Okay, now we're loading here. So I'll give this just a moment while this pops open. Okay, everything looks like it's done loading here. So let's go ahead and jump back to our tasks. So we need to load the registry hives. Once the Registry Explorer opens with an empty interface, follow these steps to load the hives. We can click the File option from the pop menu, or top menu, not pop menu. Select Load Hive from the drop-down, and then 3, Handling Dirty Hives. Wow. So we're going to click File, and then Load Hives. File, Load Hive. And then for us, while loading registry hives, it is important to note that these registry hives can sometimes be dirty. Well then, when collected from live systems, meaning they may have incomplete transactions. To ensure clean loading on the load hives pop-up, navigate to the Users Administrator Desktop Registry Hives. So Users Administrator Desktop Registry Hives. Then we'll click Open. Come back. Select the desired hive file. Example given, System. So we'll click System. We'll hold Shift, then press Open to load the associated transaction log files. This ensures you get a clean, consistent hive state for analysis. So Shift to then press Open. So scroll down to System. Shift, Open. Just make certain that we're doing the right thing here. You'll be prompted with a message indicating successful replay for the transaction log. Repeat the same process for all other hives you want to load. So I'm assuming we just press OK. And after loading the system hive, you can navigate to the specific registry keys for investigation. Let's practice by finding the computer name. Okay, so by doing so, we can navigate to root, control set 001, control computer name, or you can also just type in computer name in the search bar to quickly locate the key as shown below. Well, what fun would that be? Control set 001, and was it control? And then computer name. This one here, this one here. Alternatively, you can click on the Available Bookmarks tab to navigate to the computer name key. From there, examine the values to identify the system's host name. Under the data value, you'll find dispatch serve 01, which is right here. Now that you understand how to load the hives and navigate in Registry Explorer, you're ready to begin your forensic investigation and uncover evidence of the TBFC intrusion on the dispatch server. Note, the abnormal activity on dispatch serve 01 started on the 21st of October 2025. Tip, the table given in the Registry Forensics explanation is going to be your friend. So what application was installed on dispatch serve 01 before the abnormal activity started? Well, let's see here. Let's go back. Let's close all this stuff down if we can. Let's close this one down. By the application, maintain the persistence on startup. What application was installed on dispatch serve 01 before the abnormal activity started? Sorry about that. Clearly tongue twister for me. All right, let's go up here. HKLM, software, Microsoft Windows. Software, Microsoft Windows current version uninstall. Is that where I need to go? So which one do we update here? Let's do software. Load hives. Shift open. Okay. Out of my own curiosity, I wonder if it takes this one away and just replaces this hive. Okay, so I can click here, right? Oh, cool. Okay. So we'll do root. Microsoft. Scroll down. Hopefully I'm on the right path here. Windows. Current version uninstall. We'll do current version right here. This one here. Oh, wait a minute here. I don't know when things became abnormal though. What application was installed on the dispatch serve 01 before the abnormal activity started? We did this. Did control. Okay, so we have computer name dispatch serve 01. But does it give us any indication on where things went abnormal or before or thereafter? I see nothing. So let's close this one. We got this one open. Microsoft. Let's get down to Windows again. So we have that open, current version open. Display, publish, install. Let's go widescreen here. Well, again, you got to remember, I am a beginner here, so I'm not entirely certain what I'm even looking for. And leave it to the explanation here. Abnormal activity started on dispatch serve, started on 21st October 2025. Okay, so let's go to, we're in this. So let's do this here. Oh, good night. So abnormal activity started here. Okay, so we have dispatch serve 01 before the abnormal activity started, which started on 21st October 2025. And I see October 21st, 2025. And I see we installed something here, which appears to be Google Chrome. I also see this here. So what are we looking for exactly? So this key stores information. The installed programs refresh the memory of the registry keys table. That's where I went. Okay. And root integration. Well, two things I did notice. I don't know if that makes a lot of difference or not. Let me try. And we're looking for the key name, right? Key. This key stores information on the installed programs. Okay, I'm definitely in the right spot, which is good stuff there. And this is a little bit too far back. TBFC drone systems. Drone manager updater? Would that be it? Drone manager updater. Oh, nice. What is the full path where the user launched the application found in question 1 from? What is the full path where the user launched the application? Okay, so let's go to see where applications were launched, right? A little bit higher up. Stores the path of the applications. So we just need to go to software, Microsoft Windows, current version, app paths. So let's go to app paths right here. Let's go back to uninstall. Change our timestamp again. Let's go back to our question. Check out our hint. So user.dat, this key stores information recently asked us. Okay, so let's try this. Load Hive. Grab that one, shift, open. Okay. Let that sucker load. And while it's doing that, I'm gonna grab a sip of water. And now we need to figure out where that was launched from. So we'll do root. Let's go up here and figure out that path. Software, Microsoft Windows, or root software, Microsoft Windows, current version, app, compat, flags. Holy moly. Windows current version. Oh, come on. Because I resized the screen. Software, Microsoft, Windows, current version, Explorer, user assist. Let's just click this. There we go. C4 /users dispatch.admin. Let's grab our notes. For whatever reason, I'm not able to copy. And then users dispatch.admin. _ setup.exe. Let's try writing that again. exe. Copy. Nice. Which value is added to by the application to maintain persistence on startup? This key stores information on the programs that are set to automatically start when the user logs in, navigate to, root, Microsoft Windows current version, run. So let's do current version, run. Let's do this. Which value was added by the application to maintain persistence on startup? Oh, now I'm able to copy. There's no way that's correct. Yeah, I was about to say that it looks like it's copied in there, oddly. So we'll go back. Oh, I bet we copy the full string here. Still looks improperly copied. So we're going to back out of that. Bring our notes back up here. Program files, Edge application, msedge.exe. Well, clearly that's not it. I don't think that's it. I think the program files. Let's check our hit one more time. This key, start when the user logs in, navigate to software key. This key stores information on the programs that are set to automatically start when the user logs in, navigate to root, Microsoft Windows current version run. That's what we did. Let me check this real quick. Okay, so this is under software key. Okay, so we're in software now. Sorry for the ping one more time here. Microsoft Windows current version run. Microsoft Windows current version. There it is. Run. All right, third time's charm, right? So let's hope it's this one here. Copy. That's not it, huh? Okay. Let's run this whole piece. Finally. All right, cool. Check this off. Continue. How long do you keep your skills sharp? We'll just commit to 30 days. Close that. And then we'll go ahead and terminate this. Close this. Just to make certain, we'll terminate that. And thankfully, that's going to be it for day 16.